So we've already talked about ions, cations, anions, what they are. The next, and actually I think the last thing in your chapter 3, is understanding how elements and compounds are written. We looked at the symbols for elements the other day. AR is the symbol for argon, uppercase, lowercase letter. C is the symbol for carbon, a single uppercase. Cobalt is uppercase C, lowercase o. Oxygen, the element is written, its symbol is O, but whenever we use it in an equation, we're going to use O2 with the subscript 2 because it's a diatomic element. So 2 is a subscript, and we're going to talk a lot about subscripts today because subscripts multiply the thing directly in front of them. So let's go on to writing compounds. Compounds, as you recall, are made of 2 or more elements bonded together. That's as opposed to a molecule, which is 2 or more atoms bonded together. So compounds have to have 2 different kinds of elements. So for instance, if we write the formula for sodium chloride, NaCl, there's 1 sodium and 1 chloride, so our ratio is just 1 to 1. Notice there's a single symbol for sodium, nothing to modify it like a subscript, and a single symbol for chlorine. However, if we write CO2, carbon dioxide, this is telling us there's 1 carbon. Whenever there is an absence of a subscript, it means there's 1 of that element, and there are 2 oxygens. Okay, 1 carbon to 2 oxygens. The subscript modifies whatever comes directly before it and has no bearing on anything before that. So it modifies the oxygen. It says we have 2. It doesn't do anything to the carbon. No subscript is the same as a subscript 1. It's understood to be 1. You can have subscripts on 2 different elements. Al2O3, aluminum oxide. This is telling you have 2 aluminums to 3 oxygens. Now, the subscript 2 in oxygen isn't required here because oxygen is not alone. It's part of a compound. Okay, so the only time you're going to have that subscript 2 by the polyatomic elements is when they are alone. Like if I write Al plus O2 and I want to make aluminum oxide, then the oxygen has to have a 2. So this is telling me there are 2 aluminums because the subscript 2 refers only to the aluminum. The subscript 3 refers only to the oxygen. In total in this compound, we would have 5 atoms. 2 plus 3 is 5. Okay, so the subscript tells us how many of anything there is in a compound. Subscript. How many of an element or ion, we'll do the ions in a minute, are in a compound. Okay, and remember it refers, so subscript tells you how many of an element, or possibly an ion, are in a compound. And the subscript refers only to what's immediately before it. Okay, so next we'll take a look at what are called polyatomic ions. The word polyatomic, or poly, means many. So these are many atom ions. They might only have 2 atoms, they might have 4, they might have 6, but they are many atom ions. Most of the polyatomic ions are cation or are anions. There are only 2 cations. You don't really have to worry about that right now. But suppose examples of them would be things like the nitrate ion, NO3, with a -1 charge. That extra electron is spread around the 1 nitrogen and the 3 oxygens, or sulfate, SO4, 2-, where the 2 extra electrons are spread among the 1 sulfur and the 5 oxygens. 4 oxygens. Don't worry too much about where they are. So suppose we want to write a compound with a polyatomic ion. So let's take aluminum, and I know aluminum is going to bond to 3 nitrate ions. Okay, here's a nitrate. And aluminum always bonds to 3 of them. So it would be like this, sort of. But this is rather cumbersome and it takes up a lot of space, so we're not going to do that. So if I wanted to count up how many of everything, I would take a look at my aluminum. There are no subscripts by it, so I have 1 aluminum. And now I have this bunch of stuff, the N's, the N and the O's inside the parentheses, and I have a 3 outside. This 3 outside refers to everything in the parentheses. It means I have 3 nitrates, just like I did 1, 2, 3 over here. So if I want to count up the nitrogens, I would have 3 nitrogens, because I have 3 of these nitrate groups, and I would have 3 times 3, or 9 oxygens. Okay, so again, the subscript refers to only what's immediately before it. What's immediately before it is in parentheses, so everything inside the parentheses gets multiplied by 3. The oxygen was multiplied by 3 before that, and the aluminum is still 1. Now, I could have a polyatomic ion like sodium nitrate and NO3. There's only 1 sodium and 1 nitrate ion, so I'd have 1 Na, 1 N, whoops, that's 1 N, you can't tell, and 3 O's. But right now we're dealing with the parentheses. Lastly, we're going to talk about coefficients. Coefficients go before. Okay, you see them before a compound or an element. And they tell you how many of the compound or element you have. How many of the compound / element you have. You are going to see coefficients in balanced chemical equations. So for instance, if I wrote 2H2O, that would mean I would have 2 water molecules. So I could write that as H2O plus H2O, or I could draw pictures, O and H, and O and H, like that. But that just means I have 2 water molecules. So if you're totaling things up and they're more complicated, the coefficients can be problematic. Now suppose we had 2 aluminum nitrates. All right, same thing as this guy, but now we have 2 of them. What do? First thing you do is tally everything up the way you did before, ignoring the coefficient. And you look at this and you say, aha, no subscript here. I have 1 aluminum. There's no subscript by the N, but it's inside the parentheses, and I have 3 of everything inside the parentheses. So I have 3 nitrogens. Here I have a subscript 3 by the aluminum, or by the oxygen, and that is also multiplied by 3, so I have 9 oxygens. And now I'm going to take this whole thing and I'm going to multiply it by 2 because of this coefficient. So that gives me 2 aluminums, 2 times 3, 6 nitrogens, and 2 times 9, 18 oxygens. And you guys are going to be doing a worksheet just like this in about 2 minutes. Goodbye.